Hi, my name is Clair Behrens.
I'm Amber Hoyt.
I'm Ethan Schneider,
And I'm Reindl
and we are Group 1 from the Spring 2025 IMSC Capstone class at Iowa State University. We partnered with B&G Foods out of Ankeny, Iowa, and were tasked with creating a system to track settings used by operators at the bottle filler. Our scope was narrowed down to lines 8 through 11, which run B&G's 1-pound chef bottle line of products, specifically focusing on pepper products. The filler is comprised of 4 main components: the turret, which rotates bottles through the filling system, the auger, which forces product through a hopper located above the turret, an airlock located on the hopper, which provides airflow to prevent clumping of products, and an agitator on the turret, which vibrates bottles to help settle product to the bottom of the bottle. Our objective was to increase production by creating a database to track metrics on the filler system and relate it to a product's bulk index to create up-to-date work orders.
Through our current state analysis, we focused our efforts on how the bulk index correlates to the product density. We found that the BI changes based on the growth conditions of the spices. The turret controls the BPM at a near 1-to-1 linear relationship. The auger controls bottle weight and fill. The agitator assists the auger, and the airlock is rarely used with pepper products. Next, through our data collection, we averaged our bottles per minute of all our observations and found that it was 23% lower than the expected bottles per minute. B&G allows for 10%. Next, we wanted to use an AS400 system that B&G already uses to create work orders and collect and store the data. They use a secondary system, JD Edwards, that collects and stores the bulk index data, but they cannot be integrated into each other.
While collecting data, it became apparent that B&G needed a long-term solution to collect production metrics. So we met with their senior developer and analyst to come up with an AS400 data entry template that would be able to send reports to upper management, who could then export it to an Excel file. The photo shown is our final template, with all the metrics that could usefully be compared to the BI of the product. Currently, the data is only collected on lines 8 through 11 when the operator chooses to input the data. In the future, operations could be expanded to all production lines, and the frequency of data collection could be changed. How often the data is reviewed by management could also be set to a specific time each week or even bi-weekly.
Standardizing this process will improve the bottles per minute to a target area of 80 to 100 bottles per minute. This implementation will lead to a potential increase of 760,000 bottles per year, with an estimated potential ROI just for line 9 would be around $368,000 per year. This process would also reduce product waste, time wasted adjusting the settings, and the need for overtime to keep up with product demand. With that, this process will increase production, which will ultimately increase profit. Thank you.